Hello students. So the next part in this chapter, laws of chemical combination, is we have three more laws pending. In the first video, students, we completed the law of conservation of mass as well as law of constant proportions, law of definite proportions. Like a single in 2 minutes, let us recap about the laws. So law of conservation of mass means matter can neither be created nor destroyed. That means the mass of the reactants is always same as the mass of the products, right? That is law of conservation of mass. Then what is the law of definite proportions or constant proportions? The elements always combine in any particular compound, elements always combine in a fixed ratio by mass. That means CO2 here or anywhere always contains 12 grams of carbon, 32 grams of oxygen. H2O anywhere always contains 2 grams of hydrogen and 16 grams of oxygen, 1:8 by ratio by mass. Okay, that is fixed, that is constant proportions by mass. So next we have in the next part is law of multiple proportions as well as Gay-Lussac's law of gaseous volumes and Avogadro's law. We'll discuss in this video. First of all, law of multiple proportions. So you already know, students, all these laws provides the basic rules for chemical combinations. If two elements are combining, two compounds are combining, so what are the principles which are acceptable for these combining elements? What are the things step by step, rule by rule given by all these laws? So first of all, here law of multiple proportions means, students, simple. This law is also very simple. If two elements, if they combine to form more than one compound, what is that? If two elements combine to form more than one compound, they always combine in a simplest whole number ratio. For example, carbon oxygen, students, carbon oxygen. How many oxides we can expect? Two. One is carbon monoxide, second one is carbon dioxide. Now let us find the ratio by atoms. Find the ratio, 1:1 ratio, right, correct. In CO2, 1:2 ratio, right. Now here the point of discussion is law of multiple proportions is, students, oxygen 16 grams combines with carbon 12 grams in carbon monoxide. In carbon dioxide, how much? 32 grams of oxygen. Two are there na, CO2 combines with 12 grams of oxygen. Now this oxygen are in what ratio, students, in both these compounds? 16:32. That means 1:2 ratio or not, or 32:16, 2:1 simplest whole number ratio. That means if the two elements combine to form more than one compound, they always combine in a simplest whole number ratio. Water, H2O, hydrogen peroxide, H2O2, SR, sulfur dioxide, SO2, 1:2 ratio. Sulfur trioxide, what is the ratio? 1:3. Understood? So that is what the law explains. So this law states that if two elements combine to form more than one compound, the masses of these elements in the reaction are in the ratio of small whole numbers. This law is given by the Dalton in the year 1803. It's simple, basic. These are very basic laws for combining elements. For example, considering that two of the carbon oxides, like this example we already discussed just now. So CO and CO2. So here, students, some 100 grams is taken. I already have explained this point about what is the mass of carbon, 12 grams. What is the mass of oxygen? 16. So what is the ratio? Right. What is the mass of carbon? 12. What is the mass of oxygen? 16 only. But how many are there? 2 are there. 2 into 16, 32. Now find the ratios of only oxygens which are combining with same carbon, 16, 32, which is 1:2 ratio or not, or 32:16, which is 2:1 ratio or not. That is the ratio that this law of multiple proportions is talking about, the Dalton is explaining about. So 100 grams of carbon react with 133 grams of oxygen. Okay, 100 grams of carbon reacting with 133 grams of oxygen to produce carbon monoxide, CO, correct. Now you answer, students, if 100 grams of carbon is combining with 133 grams of carbon to form carbon monoxide, to form carbon dioxide, 100 grams of carbon reacts with how many grams of oxygen? You answer. Obviously double, right, students, which is 266 grams. So the or 266 grams of oxygen to produce carbon dioxide, 1:2 ratio, sir, no, 2 into 133. So the ratio of the masses of oxygen that can react with 100 grams of carbon is 266:133. So what is the ratio? Cancel out, which is equal to 2:1 ratio. The ratio of the small whole numbers, This law of multiple proportions is just what the name suggests. This is the law of multiple proportion is one of the constant element within differing compounds is sharing the same type of chemical bonding. Here one element is common, single element. Other element is always combining in a simplest whole number ratio, that is multiple proportions in different compounds, which these compounds are made up of same elements. Understood? That is law of multiple proportion, students. So we have an example here for explaining law of multiple proportions. It can be illustrated by examining the elemental composition of two bromides, one is of copper, one is cupric bromide, cuprous bromide. What are the formulas? Cuprous bromide is CuBr, students. Cupric bromide is CuBr2. Cuprous, cupric. CuBr, CuBr2. Here bromine is in which ratio? For in cuprous, one bromine is there, one copper is there. In cupric bromide, one copper is there, and how many bromides are there? Two are there. Leave the masses. By atoms are the what ratio? 1:2 ratio, right? This is explaining in terms of their masses. That's it. Of course, if we cancel out the masses, for example, if bromine is 80 grams, 2 are there, 160, 80 is to 160, how much, students? 1:2. Understood? Got the clarity? That is law of multiple proportions. So here colors are also given for these different compounds. So bromides of cupric bromide, cuprous bromide, a black powder and a dark green powder respectively, whose composition can be readily determined. This compositional information can be then used to form the following mass ratio, which is accordingly inconsistent with Dalton's law. Students, listen. Here this composition, first of all, copper CuBr, here also copper is there, bromine is there. Are these two compounds same? Are these two compounds same? No. These two compounds are not same. Why? Because here one extra bromine is there, sir. That's one is called as cuprous bromide, other one is called as cupric bromide. CuBr, CuBr2. That means what, according to the Dalton's law also, elements always combine in a fixed ratio to form a certain compounds, right, students? So here also these two compounds with different colors, if you want to check the composition, we have a ratio to find the composition. For example, students, if you heat this cupric bromide, which is CuBr2, what we will get is cuprous bromide plus bromine gas will be released, Br2 will be released, and again by action of cuprous bromide with nitric acid is one of the oxidizing agent, best oxidizing agents. Copper becomes copper oxide. So why I am explaining all this, I'll tell you, just wait. When this copper oxide, when it is treated with hydrocarbons, ultimately we will get pure copper. Ultimately, why we are doing all these reactions? To obtain pure copper, and some carbon dioxide will be released. Yes or no? Now we can weigh the mass of copper or not. So how to find the percentages of these elements? We have formula. Mass of copper by total mass of the whole compound into 100. This is the percentage. Students, if you find the percentage of copper, 100 minus percentage of copper, what is the remaining percentage? Percentage of bromine, right? So if by examining the percentage of bromine in CuBr and CuBr2, cuprous, cupric, you will find the ratio. Now you answer, what is the ratio? What is the ratio of bromines which are combining with copper? 1:2 ratio, yes or no? By atoms you can answer, yes or no, students? So that is what the whole theory is about, by finding the mass ratios and all. So ultimately, in order to find the multiple proportions of bromine which are combined with copper, cuprous, cupric, CuBr, CuBr2, right? So students, next we have Gay-Lussac's law of gaseous volumes. So Gay-Lussac's law is all about almost like the law of constant proportions only. Law of constant proportions is like explaining by examining the mass, as a fixed mass. Here simple volumes, that's it. That's the difference. Constant proportions is by mass, and Gay-Lussac's law is by considering the volumes. What are volumes? That I'll explain. In 1808, Joseph Louis Gay-Lussac gave this law based on his observations. This law states that, this law is very, very important, students, in stoichiometry also. When gases are produced or combined in a chemical reaction, they do so in a simple ratio by volume. Given that all the gases are at the same temperature and pressure, the ratio between the volumes of the reactant gases and the product gases can be expressed in a simple whole number ratios. That means the gases which are combining in a reaction And by analyzing the gases which are produced in the reaction also, if you examine all the volumes, they are in the simplest ratios only, simplest whole number ratio. That's the mean. This will explain the experimental facts about the how gaseous atoms are combining. So simply student, this look at here, some examples are given here. So N2 plus 3H2 gives rise to 2NH3. So how many volumes here? One volume of N2 is combining with 3 volumes of H2 produces how many volumes of ammonia? 2 volumes of ammonia. Volumes means nothing but moles only in general. Volume is directly proportional to the number of moles, which is the coming law, Avogadro's law. There we'll discuss. So 1 mole of N2, 1 volume of N2, for gases we used to express by volumes, combines with how many volumes? 3 volumes, yes or no? So can we change this? That is the simplest ratio. Simplest whole, that is fixed. Can you change that? If you take 2 volumes here, this becomes 6 volumes and this becomes 4 volumes. What is the simplified ratio? 1:3:2. Understood? Got the clarity, students? Can you simplify further? No, you cannot. These volumes are fixed for fixed reactions, for some fixed chemical reaction. That is what Gay-Lussac is explaining. What is explaining? The gases are combining in a simplest whole number ratio by volumes, by mass, constant proportions, by volumes, Gay-Lussac law. And look at this reaction. 2H2 plus O2 gives rise to 2H2O. Here how many volumes of hydrogen gas we have? 2 volumes of hydrogen gas combines with 1 volume of oxygen produces 2 volumes of water. Yes or no? That means 2 moles of hydrogen gas combines with 1 mole of oxygen produces 2 moles of water. For example, if I take here 4 volumes of hydrogen, so still does it react with 1 volume only completely? No. If it is 4 volumes, it becomes 2 volumes and this becomes 4 volumes. Simplify the ratio. 4:2:4, which is 2:1:2. This is the simplest ratio or not? Is it changed? Can it become 1:3:2 like this? No. Every reaction has its own ratio of combinations by volumes. Volumes is nothing but number of moles. Yes or no? The number of molecules in 1 gram molar. 6.023 into 10 to the power of 23 molecules. Right, students? Gram molecular mass. So 2 volumes of hydrogen combined with 1 volume of oxygen to form 2 volumes of steam, H2O. Right. Look at this reaction, Cl2 plus H2. Chlorine plus hydrogen produces HCl. Like what are the volumes? So how to find the volumes? The number in front of the molecule. Check. What is the number in front of Cl2? 1. What is the number in front of H2? 1. The coefficient number indicates the number of moles, volumes. And what is the number in front of HCl? 2. Look at here, 1:1:2 ratio. Yes or no? All these chemicals, all these gases are combining in what ratio by volume? 1:1:2, which is the simplest whole number ratio. That is all about Gay-Lussac's law of gaseous volumes, combining volumes also. Understood, students? So right, next, Avogadro's law. Avogadro's law gives the relation between volumes and number of moles. Volumes and number of moles. Students, answer. If number of moles are more, volume is increased or decreases? If number of moles means number of moles is directly proportional to the number of molecules. Yes or no? If number of molecules are increasing, volumes also increases. So volume is directly proportional to the number of moles. That's what Avogadro's law. Avogadro proposed this law in the year 1811. It is stated that under the same conditions of temperature and pressure, equal volumes of all gases contains equal number of molecules. Sir, how? Why? Because students, equal volumes means equal moles. 1 mole of any molecules how much? 6.023 into 10 to the power of 23 molecules. Yes or no? Is that number changed? No, it's constant. Avogadro's constant, that is fixed. Equal volumes of all gases always contains equal number of molecules under the same conditions of temperature and pressure. That is Avogadro's law. So here this implies that 2 liters of hydrogen will have the same number of molecules as, students, 2 liters of oxygen, given that both the gases are at the same temperature and pressure. 2 liters of hydrogen or 2 liters of oxygen, they contain same number of molecules at fixed temperature, constant temperature and pressure conditions. Another statement, volume is directly proportional to the number of moles. Right, just now I have said that the volume increases as the number of moles increases. It does not depends upon the sizes of the masses of the molecule. That means more is the mass, more is, no, it's not like that. It is all about the count of molecules, number of molecules. That is application, students. Volume is directly proportional to the number of molecules. You can see the expression here. Volume is directly proportional to the number of moles. Number of moles is directly proportional to the number of molecules. So V is the volume and N is the number of moles. V by N equal to constant. This constant is called as proportionality constant. Many students have doubt about this proportionality constant. We have all this constant everywhere in this gas laws. So what is this constant about, students? For example, if something is changing, like if volume changes, number of moles changes, yes or no? By changing by how much? It depends upon the number. Any number it can be changed, right? Got the clarity? This change is constant. What does it mean? For example, students, 4 by 2 how much? 2, right? 8 by 4 how much? 2, right? 16 by 8 how much? 2. 32 by 16 how much? 2. 64 by 32 how? 2. You know, these are all changes, right? All these numbers same? No, different numbers, but they are changing in a fixed ratio, yes or no? That is proportionality constant. If a change is happening, that change is happening at a constant rate. That constant is called as proportionality constant. So we have initial and final variables, students. If V1 is the initial volume, N1 is the initial number of moles, and if V2 becomes final volume, N2 becomes final number of moles, and the relation is V1 by N1 equal to V2 by N2. This formula is very, very important. Avogadro's law, in gaseous law also, gas laws, we'll get this equation, students, right? So that's it. Simple concept, simple chapter. This chapter explains the law of chemical combinations. Once again, what are the laws? We have law of conservation of mass, explains about matter can neither be created nor destroyed. Law of definite proportions explains about in a compound, elements always in a fixed ratio by mass, law constant composition. As well as law of multiple proportions means what? If two elements combine to form more than one compound, they always combine in a simple whole number ratio, multiple proportions. What is Gay-Lussac's law, students? Gases always combine by volumes with same simple whole number ratio, right? In terms of mass is constant proportions, in terms of volumes is Gay-Lussac's law. And what is Avogadro law? Volume is directly proportional to the number of moles. Volume indicates number of moles only. That means equal volumes of all gases contains equal number of molecules only. 1 mole equal to 6.023 into 10 to the power of 23, Avogadro number. So that's it about all these 5 gas laws, which provides the basic rules and conditions for the combining elements and compounds. I hope you got the clarity, students. That's all for today. Thank you.